Okay, so as part of roofing structures or building a roof frame, there's one of the basics we need to try to understand, and that is angles. Now this is your handout sheet you've got here, and as part of roofing structures you're required to build a small roof with one gable end and with outriggers and one end a hip style. Now a gable end just means it's like this, and a hip means it's a bit like your hip where the two sections come together, they form a hip. Okay, so the specifications are the top plate or double top plate. We want the wall to the house or the wall frame to be 1 metre by 2 metres. We want the roof pitch to be 22.5 degrees. We're going to overhang our gable by 300 millimetres, and then we want our eave overhang, which is at the level at 200 millimetres. So step one is to build your double top plate, and this will represent the top of the walls, which you've already should have done by now. And next is to calculate the common rafters using a rafter table. Now, basically, a roof is from a rectangle. Okay, so this represents half a roof, half a span. This represents here the eave, which has a level overhang of 200 millimetres. And this is the stud wall. Now on here I've got a table, and this table we need to fill these out, so we need to figure out what our run and our rise is, and we need to figure out how long it is from here to here. Now this is mostly trigonometry, you can do it with trigonometry, but there's another thing that's called a roof book or a little red book, roof cuts and rafter lengths. Now if I open this up, because it's all to do with angles, you'll see that there's a lot of stuff in here that helps you with regard to how to do your cuts and how to do which angles to do them at, because it is quite complicated. Remembering, building a square is easy, but once you build a triangle, it becomes a lot more complicated. So this is a little book that a lot of people have or used to have. So what we do is we go to these tables. So these tables is basically, it tells us for however much the angle is, it'll tell us for every run, it'll tell us what the rafter length is, or the hypotenuse of the triangle. So if I look at this one, it says 4 degrees and 34 minutes. Here it says 5 degrees and 43 minutes. And for every 0.1 of a metre, it rises, the 0.1 metre rise from a 1 metre run. So there's all these different angles in here, and all these will be different figures, but we want to get to 22.47. So I'm going to open this up to 22.47. 27, 25, 24, 23, 22.47. Now what I have done is I've actually photocopied it and put it on the back here. So this is a larger copy of it. So what we have here is a bit of information. We have here that for every 1 metre of run, it'll rise 0.420 of a metre. And that's the angle that we want, 22.5 degrees. Now here it says rafter lengths, and here it says hip and valley lengths. Now why there's two different tables is because the hip and valley usually have a different angle. If we want the roof to be all of this, the hip and the valley ends up being a different angle and different measurements, so that's why it's a separate table. But for the moment we want to concentrate on the rafter length, which is the hypotenuse. So according to this, it says here, for every 1 metre run, it rises 0.420 millimetres. So for here, I've got 0.5 of a metre. So for every 1 metre, it rises 0.42 of a metre. So 500, what will half of 500 be? Half of 420. So that'll be 210. And then we've got 200. How much will that be? So we need to figure out what the rise will be for 200. Okay, that will be, and I know what it is because I've got 100 here, sliding bevel to set the angle. It's actually going to be 42 So if this is 42, double this is 200, that's going to be 84. Now if I go to my table, don't worry about this. Okay, we'll go to a table and we want the rafter length. We want a half span because a roof will span a certain area. So if it's 3 meters, your half span is going to be 1 meter. Our span is 1 meter, so our half span is going to be 500 meters. So 0.5, not 500 meters, 0.5 of a meter. If it's going to be 1 meter, it's going to be 0.5 of a meter. So if I go down here to 0.5 here, if I go to here, 0.5, it tells me 542. So the rafter length is going to be 542 millimeters. Now I can do the same with the hip. We're going to worry about that later, but we can do the same with the hip. 738. You can see that this is longer. This is a longer piece. Now for the eave overhang, this is this section here, 200. So we want to go to 200 here, and it's 217. 217. And then for the eave overhang, 200 here, 295. For the moment though, we just want to concentrate on this rafter length. Now what we want to do is we want to check these angles, all right? So we're going to use Pythagoras' theorem. So this is going to be A, B, C squared, okay? So we know that A is 500. So A equals 500. So A squared, or 0.5, I would rather say 0.5, it makes it a bit easier. So if I use a calculator, 0.5 times 0.5 equals 0.25. Now B, the height, our height was 210. So 0.21 times 0.21 equals 0.0441. So if we add these up, 0 and 1 is 1, 0 and 4 is 4, that's 9, 2, 0.2914. So 0.2914, the square root of that will equal 539, 0.539. That's something's gone wrong there. 0.210 times 0.210 equals 0.0441. Add the two together. I think of 0.5 times 0.5 equals 0.2941. Oh, 5, yeah, that's right, 542. Right, 542. So we square rooted this and we end up with 542, which is the figure that we calculated here. I did get it right. I got myself muddled up there. So we've double checked with Pythagoras' theorem, so these measurements all work together. So we know that the rafter length is 542 and 217. So that's that part of the question. So our pattern rafter, so when we're making the pattern rafter, the rafter tail length is going to be 217, and this rafter length is going to be 542.